But it's starting. Yeah, Anand, please get started.
Yeah, as I indicated, I am Anand, working in Siemens Healthineers as an architect lead. So together with Vijayendra and Maruti, we would be presenting our experience with the smart health cards using FHIR. So we did participate in a recent Connectathon, International Connectathon, which was in May, where we actually participated to contribute implementation for IG, Smart Health Card IG. We went through and we implemented the actors in that one. We participated, we passed those tests as well. So those details we want to share. So first, in few slides, I would explain about Smart Health Card and its implementation detail, and then we will show the demo of what we have done and also our experience on Connectathon. So let me just go to first slide. This is smart health card use cases. What is smart health card? It's basically health card is a kind of a digital version or a paper version of your clinical information, such as vaccination or even the test results. So you basically will be able to share this information with others, maybe for verification, or there are several use cases. You can just see the use cases which are mentioned here. So currently we are in this unprecedented scenarios of this COVID-19. So what happens, let's say we want to return to office. All of us are taking vaccines and someone has to verify whether the guys who are returning to office are really vaccinated. To do that one, we could use this smart health card mechanism, and maybe for kids also, if they want to go back to school, or registration, if they want to check whether kids are kids have taken the taken the vaccine. That part probably we can again represent with smart health cards. And even travels nowadays, I think this is something which is being discussed a lot. Vaccine passports, where you have all the information about vaccines, which are all vaccines you have taken, and present that vaccine detail as QR code so that it can be easily scanned at airport and you are allowed to enter particular country actually. So this is one more use case. And about clinical research studies, I think this is anyway the normal use case. So currently this IG, Smart Health Card IG, mainly focused on COVID-19 status to start with. It has again, as such, IG is generic enough, but even when we are talking of testing and verification, main focus is on COVID-19 part. So let me just give a brief background of what is this health card all about. So there are basically three actors. You can see that there is a issuer, there is a holder, there is a verifier. So basically health card, first you will get it. How do you get it? So there are agencies who will give you this health card. What are the agencies? Either it could be lab, or it could be pharmacy, it could be or healthcare provider, EHR, or any government organizations, or it could be even immunization information systems. These are the agencies which can issue a health card. So there are other possibilities as well, where you can demand or you can request, instead of them giving the information as part of let's say a printed certificate or printed or QR code. You can also use some APIs to do that one. I'll explain how we can do that one. And holder is a use case where you store it. So you got that vaccine from agencies, you store it. You either store it in the form of let's say printout, take a printout, keep it. That's a lame use case, or a digital use case where you can actually store it in your health wallet or vaccine passports kind of a scenarios. These are holder applications. Third one is verifier. This is where you actually present your health card to somebody who can verify and say that yes, it is signed by proper authority and it is actually correct, and this information can be used further. So this is basically the concept of health card. So there is a issuer who will sign and give it to you a card, which you can store it and you can present it to verifier, where they will verify the signature and say that yes, this is proper. So in the connectathon, and the IG, there were scenarios where we had to implement this holder, verifier, and issuer. Our prime focus was to implement holder and verifier so that we can test the IG properly. In addition, we implemented issuer as well, but we did not really participate in checking the interoperability with issuer, but our focus was on this holder and verifier. So what we did is basically we developed an application which satisfies these three requirements. One requirement was to get these health cards using FHIR APIs. How do you get that API? The EMRs or EHRs will provide an API in FHIR on particular patient with the ID. There's an operation called health card issue with required parameters you will have to send, and you will get a response which is a health card, and that you store it in health wallet. And this QR download, we also implemented QR download. So you scan your QR code and basically that health card we download and we store it. There's also this file download directly. So this scenario where you get into a clinical system, sign in with your whatever credentials, and then you get that file, and that file you can download from their portal and store it. So all these things you can actually get verifier into picture for validation. So here there's also integration with Smart on Fire, because once you want to get to this EMRs, you just have to go via Smart on Fire interface to authorize yourself for basic resources. What kind of resources we need? Probably I'll just go in and then in the next slide. So in this slide, the focus is mainly on explaining the conceptual model. So next, see, you have health card. There is always kind of a worry that is it disclosing too much of information, or is it really safe? We can present it anywhere. Can somebody steal our personal data with this health cards? So IG very clearly talks about this privacy aspects. Okay, they say that there are two things you have to very clearly take care. One is the data minimization. So that means you should give only that information or only disclose only that minimal amount of information which is necessary for creating the health cards. Should not disclose too much of data. And granular sharing, that means you should ensure that you share only that information which is sufficient and which is required for that particular use case. For example, take a COVID-19 immunization scenario. Then you should disclose only the immunization information that is relevant to COVID. If you have taken vaccine for other things, that information should not be shared with the health card what you are presenting for COVID-19 health card. So this is what is granular sharing. So here it is very important that you provide access as a data holder, you provide access to only those information which are relevant. For example, COVID-19 health card, you need only the patient information, that too very minimal information, and immunization resource. Only these two are needed. Or if you want to go with the lab result, you probably need a diagnostic report and observation, nothing else, nothing more than that actually. So what IG recommends is you should provide the details like a legal name, DOB, and manufacture. If it vaccine information, you can provide what is the type of vaccine, when did you take, or if it's a lab test, who provided that test results, what are the test results itself, when was it performed. You should not disclose these details like phone number, address, or any personal IDs as well. It is not recommended to put it in this health cards actually. So that you don't disclose too much of information. So now in next few slides, what I will do is I will explain what is this health card all about, how do you really create a health card actually, so that you can understand this overall format better. So finally, I mean, step by step, if you just go to create health card, so you will start with basic FHIR data. You will start with sharing, let's say I'm creating COVID-19 vaccine details, immunization card. So I'll start with FHIR details which are needed. For that, I need only patient and immunization. I'll start with these FHIR resources, put those FHIR resources in a FHIR bundle. FHIR bundle, as you know, it's just a composition where you can put all the information and create a bundle out of it, FHIR bundle. And then you can put a FHIR version, and this information is called credential information. So credential information is basically FHIR bundle with information about the minimal information, patient and immunization in this case. And we will also have to put what is the type of this verifiable credential. Then finally the name is called verifiable credential. This is the one which you are going to create. So first you create credential subject, and you put details like what type of health card you are going to create. The health card, a generic health card, it is for immunization COVID-19. This is a kind of a and condition. So it basically tells you that this is a health card which contains COVID-19 immunization details. And all these details you put it in a structure, and this is what is your verifiable credential. It has ISS. Basically, this is the one which provides the detail about issuer. So you put this issuer details here. So first step, you create this credential with all this FHIR information. Next step, you basically minimize the data. So or minify the data. So all spaces are removed, and then you have a less data with removing all the white spaces. There's one more thing I want to share here. When you are creating this FHIR bundle or FHIR information, FHIR, again, IG recommends you not to pick some of the elements in the resource. For example, resource ID, meta information, and if it's a codable concept, don't take text part. If it's a coding, you don't take a display part. Resource IDs are compact, so that the whole idea is to reduce the size so that you can create a minimal information out of it. Once you create this payload, next thing is compress that payload. How do you compress? Basically use some zipping algorithm. So deflate compression algorithm is used, and you compress it and encode it using base64 URL, and your payload is ready. This is what is your payload, and to this payload you have to add JWS header. See, finally, our health card is nothing but JWS JSON web signature actually. So it has header, it has payload, and it has a signature part. So what we created is just a payload in base64 format. Now we need to add a header. Header, it is kind of a fixed header. Generally what we use is in the IG, what they defined is you should use elliptic curve as a algorithm for signing. Actually, there will be a public key, there will be a private key, and you will use a private key for signing. So you see small the key is put here actually. So it has for example, D is a private information here. Key type elliptic curve, it is used for signature, and key is P256 kind of a key. KID, basically key identifier, is basically encoded base64 encoded of a SHA-256 encrypted uh, thumbprint of the key actually. So all these things are used basically. First you create a header, you put base64 format of that header, and then you use this entire key for signing. So basically you have header, now you have body. You use this or payload, you basically use signature, you generate, you sign it, you generate signature, and that signature you attach it. Now you see that it is having header, payload, and signature, which is of your JWS format. So finally, you put that information what you have got in an array of verifiable credentials, and your health card is ready. This is what is the health card in its raw form. But we have use cases where we want to show or provide the health card in QR code. So that's the reason you have to do a couple of additional steps where you will basically encode or convert this binary format what I showed here, the binary stuff to a numerical code. So in the numerical code, there's a clear algorithm written here where you will take the character from the signed version. You take, for example, E, Y. These are the characters you take, convert them into numerical format. How do you convert it? You basically take the ASCII code of that character, subtract it with 45. Why 45? Because 45 is equivalent to ordinal value of hyphen, actually, which is the minimal thing which you use it in generating this base 64 encoded format. So you will start with that, and then finally you start converting. You will get, for each character you get a 2-digit information, you to the decimal numbers, and you take that details and start putting it in this format, SHS smart health cards with slash. So if it's only, generally it fits into one QR code, which is at basically 40 by 40 which is of size 1195 characters. Then you don't have to do additionally, but if you see more data is required, then you have to support chunking. We'll show you how chunking is will work in our demo, but you can imagine or you can think the chunking is basically you get this entire content, put it in such a way that it tells you what is a chunk number. 2/3 means it is a chunk 2 of 3. It can be 1/3, 3/3. So that means overall this entire data is put it in three chunks of 1, 2, 3, and the size is distributed. Anything more than 1195, you will have to split it, and QR basically QR you will generate a QR version 22, and then you encode that entire thing. You divide into equal parts and you create these chunks. And finally, you have this QR code which you can demonstrate, or which you can use it for all scanning. Now I would like to invite my colleague Maruti, who can show you a quick demo. Maruti, can you quickly share your screen?
Uh,
Maybe yeah. Kumar, can you please allow sharing
Yeah,
to
he can
Maruti
share.
as well?
He can
Yeah.
share.
Yeah, okay, thanks. Maruti, can you please share your screen?
yeah, thank you, Anand. Uh,
We don't see it.
So while he's sharing, one question that I had was,
Yeah.
where is it implemented? Is there any implementation already, like somebody using in production?
There are some implementation in Git, some implementations are there, some basic implementations are there. So I don't see any production thing yet, but in the connectathon, EMRs or EHRs we had implemented that one, and they had come up with their implementation. We actually tested our implementation with their implementation. So it is not productized as IG itself is, yet to make it final. It is in draft final stages. It will be finalized. So all of them came with their implementation, and we verified our implementation with them. Production, I think it will come soon. I don't see any EMRs or EHRs having that yet, but they have implemented. We will also share those, which are those EHRs which have this information. It is there in my slide. I can just show you that.
Okay, thanks. Over to you, Maruti.
yeah. Thank you, Satyam. Here, this is a app that we developed as a part of Connectathon that we participated. So here we developed the holder and then a verifier. As Anand said, we are supporting the import of health cards using a three modes of import, using a file and then by scanning QR code. And we can import the health cards using a FHIR enabled issuers like a lab or EMR, where the health information is present. So I'll start with a file import. How we can it gets imported into the vault. So here, this is an example smart card, which actually you will get it when you download this smart health card using a download option from the issuer. So you
Just imagine, maybe I can add Maruti here. So just imagine our lab guys or immunization systems, if they have a link where you can download the file, you can take that link and you can put that here, and we will basically read that complete content and show it. Go ahead, Maruti.
Yeah, basically this smart card contains verifiable credentials, which is not an encrypted format, like it's a signed format. So the holder will get it and store it, and then it also capable of displaying in a human readable format, and also it can also be same way, the way we uploaded, the same way we can also download it if you want to keep it with our in local storage, and also we can in order to share the QR code, we can also show the QR code for a verifier if they want to verify it. Uh, and also this QR code also can be downloaded if they want to keep it as a QR code instead of a smart health card in the format. This is how we can import from the file. And then next is using a QR code scanner. Share my screen. So I'll show the QR code, which is an example QR code. The same thing is being imported in the folder. The next mode of import is FHIR enabled issuers. So for this, we have developed a issuer ourselves, which is not yet compliant with the implementation guide fully. And also we support authenticated imports. As of now, we not supporting the smart on fire, that can implement it and integrate it also. We can use authentication token if it is a authenticated API. And then once I execute, you can see that the health card is imported. And also we extract the what type of health card is it from the type array that Anand showed before, and we show it as a COVID vaccination card or health card, that kind of information. And also as part of our development, we also we can see the what FHIR bundle that this card contains. So next I will show you the verifier, how it can be used to verify the smart health card. Here, as Anand said, when there is a more information present in the health card, we have to show it as a chunk, because it has to be a printable format. So we are supporting a chunk QR code display also. So for verifier, I will show it how we can scan it, the chunk QR codes, and then it get verified. So for that, the QR code I'm scanning, the means health card I'm scanning has three QR codes. First, I'll scan the one. You can see that it is showing that two chunks of three has been scanned. It means two are remaining out of three chunks. So I next scan the second one. As you can see, the health card is verified, and then we are not seeing the name and date of birth because they are hidden or not passed as part of the health card information from the issuer. And how this gets verified is that we use the issuer ISS from the JWT token, that is a JWS a payload. From there, we resolve the keys from the issuers, and then we use that same keys that issuer provides, and then we verify it, whether the signature what is provided, what is appended within the JWS payload, and then what the key they pass, if they are matching or not. And then if they gets matched, then we show it signature is verified, and then we show the information that is provided within the health card. And then if we want, we can also see the bundle that it's get shipped with the health card.
Thanks, Maruti. Maybe I can share the screen back quickly so that we try to wrap up our session with experience sharing on Connectathon. Vijendra, you're online. You can share your
Yeah,
experience. Yeah.
yeah, thanks, Anna. Hi all, Vijendra. When we attended the Connectathon, we had our holder and verifier implementation. There were multiple companies who participated in the Connectathon. So one such was MITRE. MITRE, they were the main organizers of the Connectathon, and they are the main contributors to the IG. So they had developed a issuer and a verifier application. So what their issuer did was it would just have a patient resource. You can as well upload your patient resource, and then you can just click on several buttons and create the smart health card, and you can use it as a file download or through QR code. And also they also had a verifier app, something similar to us, where you can scan the QR code and verify the smart health card. So we tested their verifier against our holder and we tested their issuer against our holder and verifier, and we were able to successfully uh, verify the smart health card that was generated by the issuer. And then second was Cerner. They had a API or a service where we could consume that service. They had two endpoints, one which was unrestricted access, and another one which had smart on fire authentication. So we tested the one with unrestricted access, and then we were able to consume the health card and then verify it. And then Microsoft also had developed a tool. So this was basically to help the participants come up with the implementation or help with their implementation. They created a tool where one can upload the FHIR resource, and also give the endpoint to public key, JWS public key, and also uh, using a private JWT key. We could create a smart health card, and then that health card could be downloaded or can be scanned, and it could be consumed. So we also tested this scenario, and it worked well. Basic highlights were these were the main three participants who had a working issuer that we could test, and other participants, they just had QR codes with smart health card data embedded, and we were not able to test it because the issuer, the ISS was not public and we could not use it. So as you can see, these were some of the test scenarios that were used to test against each application. As you can
Yeah.
see, there were a MITRE issuer with our holder and all scenarios have passed, and then Cerner with the issuer, and also C19 health cards and all those. I think, yeah. So few scenarios were tested and few were not tested. So we tested all the scenarios, and this was the result from the main organizers.
Thank you. Thanks.
Thanks,
Thanks
Vijayendra, and thanks,
for
Maruti.
this.
Yeah.
Yeah,
Yeah.
thanks for this
Yes,
presentation.
Satyam, you can.
Quite knowledgeable. We learned about the smart health cards and also a little bit about QR codes and chunking and things. So, yeah, thank you. Thanks for taking time and doing the presentation.
Yeah. Thank you.
Thank you.
And